everyone. So I'm going to do one example from section 4.4. We want to solve this differential equation, y double prime minus y prime minus 6y equals 2 sine 3x. And so to do that, well, first we're going to solve the complementary or the homogeneous version. So we want to solve y double prime minus y prime minus 6y equals 0. And so we find the auxiliary equation, m squared minus m minus 6. And everyone can solve that pretty easily. This is m minus 3 times m plus 2. And so the solutions are m is equal to 3 and negative 2. And they're both real solutions. So our complementary solution will be C1 e to the 3x plus C2 e to the negative 2x, or vice versa, right? It doesn't matter what order you pick here. So that's our complementary solution, right? So now let's look at g of x. G of x is equal to 2 sine of 3x. So notice there's no conflict here. So there's no issue at all. My guess for the particular solution should just be some number a times sine of 3x. Oh, wait, no, I'm forgetting. We also need a cosine of 3x. I probably should have done that one first, but okay. We'll make it a sine 3x plus b cosine 3x. Usually I put the cosine first, but all right, so that's fine too. All right, so now what? So we have the complementary solution, right? And now we have our guess for the particular solution. So we're going to need to plug this into the left-hand side up here, which means I need both their derivatives, right? So let's take the first derivative, yp prime of x. These are all functions of x for now. So the derivatives will be 3a cosine 3x minus 3b sine 3x. Okay, and then yp double prime of x will be, okay, let's see. So minus 9a sine 3x and then minus 9b cosine 3x. I hope that's not too messy. Okay, so that's what we have so far. So now let's calculate what y double prime minus, y double prime minus y prime minus 6y equals, right? So these are just for the particular solutions. So let's see what we get, right? So for the y double prime, it's all of this. I'm wondering if I should just factor out the sine 3x and cosine 3x here. So let's start with the cosine of 3x, right? And so we're going to get minus 9b, right? And then way over, well, let's do it down here, plus for the sine of 3x, I'm going to get minus 9a, right? So now I'm just anticipating what's to come. For the yp prime, that's this, right? So remember, we're subtracting, so that means for the cosine we're going to get a negative 3a because we have a negative sign in front. So this will be negative 3a here. And for the sine part, we're going to get a minus negative 3b, so that'll become a plus 3b here. Okay, and now for minus 6yp. So here's yp. If we multiply all this by negative 6, we're going to get negative 6a for the sine. I should do, well, okay, negative 6a for the sine. Right? And then for the cosine, we'll have negative 6b cosine. So that's another negative 6b here. Right? And so when you put this all together, you're going to get negative 3a. I'll put this in front. Negative 3a minus 15b cosine of 3x. Okay, and then for the sine, we're going to get minus 15a plus 3b sine 3x. Okay, so we have all that. Now, remember, this is for the homogeneous equation, but for the non-homogeneous, this is all equal to 2 sine 3x. So this all equals 2 times sine of 3x. Okay, so that actually gives us two solutions here. I think I'll write them up here. Sorry, not two solutions, two equations. So you're just setting the what's on the left and what's on the right equal to each other. The coefficients of the sine of 3x is 2 on the right, and it's this on the left. And of course, there's a plus 0 cosine of 3x on the right. So putting all that together, I'm going to write the system of equations up here. Oops. So let's do the cosine first. We have negative 3a minus 15b minus 15b. That's the coefficient of cosine of 3x on the left, and on the right it's just 0, so this equals 0. And then for the sine term here, we have negative 15a plus 3b, and that's going to equal 2. Okay, so you have your system of two equations in two variables. You can solve this any way you want. You know, do it by hand if you want, or use your calculator. But I'm going to skip that part because you've all done it before, and I'll just write down the solutions. A should be negative 5 over 39, and B should be 1 over 39. If I did it right, you might want to double check that. Actually, we might be able to check it very quickly. If we plug this in here, negative 3 times negative 5 is positive 15. And then we have minus 15 over 39. So 15 minus 15 is 0. So the first equation works. And then for the second one, so negative 15 times negative 5 is, well, 75. Well, that doesn't seem to work. Hang on. So, yeah, negative 15 times a is... Okay, so 75. Oh, yes, 75 plus 3 is 78. And 78 divided by 39 is 2. Okay, it works. Okay, so what that means is, if we go back to our particular solution here, our particular solution turns out to be yp of x is just going to be negative 5 over 39 times, yep, we did the sine first, so sine of 3x, and then plus b, which is 1 over 39 times cosine of 3x. So that's our particular solution. Now, to get the complete general solution here of this equation, you just add the two, the complementary plus the particular solution. So y of x, the full general solution of this equation should be c1 e to the 3x plus c2 e to the negative 2x, oops, 2x, minus 5 over 39 times sine of 3x plus 1 over 39 times cosine of 3x. Right? And that should solve the original equation. So I hope that helps. Again, if you see me doing any mistakes, let me know, and I'll try to fix them at some point. So I hope this helps. I might do one more example of this type of equation, maybe one where there is a conflict, where we do have to avoid duplication. That didn't happen here, of course. So, okay.